The isotope 98Nb has a half-life of 30 minutes. A. How much of a 100-gram sample remains after 3.6 hours? B. How long will it take until only 20 grams are remaining? This problem is dealing with the half-life of a radioactive material, and the half-life formula is the amount that you have is equal to the initial amount times 1/2 raised to the T over H power. H is the half-life of the substance, and T is how much time has progressed. And I want to remind you, you got to make sure T and H are in the same units. If T is in days, H must be in days, etc. So part A, how much of a 100-gram sample remains after 3.6 hours? We are looking for A when the initial amount is 100 grams. So A is A sub 0, initial amount 100, and we'll multiply that by 1/2 raised to the T over H. T is 3.6 hours. H is 30 minutes. So again, we need to convert units. I'm going to convert 3.6 hours into 216 minutes. And that will be raised to the 216 over H. H is 30 minutes. So when we evaluate this on the calculator, take 100 times 1/2 raised to this fractional exponent, you should get a decimal equivalent to 0.68 grams. 0.68 grams. So there's how much of the 100 grams is remaining after 3.6 hours. Part B, how long will it take until only 20 grams are remaining? So we'll start with the same formula. A equals A sub 0 times 1/2 raised to the T over H power. And now we're going to be solving for T. How long will it take for only 20 grams to remain? So our final amount will be 20 grams. Our initial amount was 100 grams, and that is raised to the 1/2, or multiplied by 1/2 raised to the T over H, and half-life, remember, was 30 minutes. So we have T over 30. And again, we're solving for T. How long will it take? Given that the half-life is 30 minutes, how long will it take for 100 grams to become 20 grams? So we'll solve this exponential equation for T, and we're going to go ahead and divide both sides by 100, and I'm also going to change 1/2 to 0.5. So dividing both sides by 100 gives us 0.2 on the left, and I'm going to rewrite 1/2 to the T over 30 as 0.5 raised to the T over 30. And we'll go ahead and take the natural log of both sides of this equation. So we have the natural log of 0.2 equals the natural log of 0.5 raised to the T over 30. Now we'll use a property of logarithms. The natural log of 0.5 raised to the T over 30 is the same thing as if we were to take this exponent and move it down in front of and multiply it by the natural log. So the natural log of 0.2 equals T over 30 times the natural log of 0.5. And again, to solve this equation for T, we're going to go ahead and divide both sides by the natural log of 0.5 and also multiply both sides by 30 to solve for T. So again, we're going to take the natural log of 0.2. We're going to divide both sides by the natural log of 0.5, so that would give us natural log of 0.5 in the denominator. And we're going to multiply both sides of the equation by 30, which would cause us to multiply the numerator of this fraction by 30. So then number crunch this expression on your calculator, and you'll get T is approximately equal to 1.16 hours. Approximately equal to 1.16 hours. And since the half-life was given in minutes, be a good idea to also have this available in minutes. 1.16 hours is approximately equal to 69.7 minutes.